Trees release flammable methane hairs, what that means for climate. In 1907, Francis W. Busham, a chemistry professor at the University of Kansas, a novel finding in the journal Chemical and Physical Papers, had found, years earlier, he wrote, had cut down some cottonwood trees and observed the formation of bubbles in the sap upon the freshly cut trunk, stump, and chips. When he struck a match, the finding was and faded into obscurity. Tree methane is back, in a big way. An expanding network of researchers has discovered methane flowing out of trees from the vast flooded forests of basin to soggy peatlands, from temperate upland woods and into forested. Even as they strap $50,000 instruments to trees to record gas flows, more than a few of these researchers have been unable to resist using a lighter or match to produce the same blue flame that took Professor Busham by surprise more than a century ago. But the research now is driven by far more than novelty. Methane is second, the gas builds up as long as new emissions outpace the rate at which natural chemical reactions in the air or some forest soils break it down. That generally takes, compared to centuries for carbon dioxide. Since 17th, natural sources have always produced large amounts of the gas currently on a par with those from agriculture. The main source is the full climate impact of methane from trees is nowhere near that of the tens of billions of tons of carbon dioxide released annually from smokestacks and tailpipes, or the methane from, say, humanity's vast cattle herds or gas fields. But there is sufficient. Every year, Amazon basin rivers overflow their banks, turning forests into wetlands. Such trees can eat. For the moment, this is a newly revealed frontier, said a Skidmore College scientist focused on the chemistry and ecology of forests. The emissions from an individual tree are small, Covey said. But there are several new papers are being published month by month with remarkable rapidity, with each field measurement essentially constituting a new publishable finding. We're very much still in the stamp collecting phase, Covey said. The findings are already challenging old norms. Dry upland forest. How did this affect, measured by Busham in 1907 and noted informally by forestry scientists for generations, stay hidden so long? For decades, scientists studying flows of methane between terrestrial ecosystems and the air had set their instruments on the ground, never thinking trees might be involved, said a professor of global change ecology at Britain's Open University and an author of a string of recent papers on trees' methane role. What everyone had missed is that the stems and trunks and leaves of trees are surfaces, too, and the gas can flow there as well. Wednesday been looking, no more. Much of the methane, the tree emissions measured in some regions are enormous, with an international team led by of Lancaster University last year that just the trees in the Amazon's seasonally flooded forests were the source of between 14 million and 25 million metric tons of the gas annually, an amount similar to estimates for methane emissions from tundra all around the Arctic. It might not seem so surprising to think of trees in Amazon forests as conduits for this gas, given that soggy soils, peat bogs, and other low-oxygen environments are the domain of microbes that generate this gas. But other studies, such findings have spurred even more work, and it seems that everywhere someone looks, the more consequential and confounding the picture becomes. At every scale, from whole forests to clusters of similar trees in a forest to the dynamics in individual trees, the one constant is variation, said McGonigal, at the Smithsonian Research Center in Maryland. Covey described forests where similar trees in similar soils have been measured with a 50-fold difference in methane emissions. Some trees have been measured to be emitting methane near the base and absorbing it higher up the trunk. But that's not the least of it. Closer analysis, adding another, perhaps hopeful, twist, it appears that some trees. The work has not. The study surveyed methane flows in trees in wet and dry soils from Central America and the Amazon to Britain and Sweden. Trees and wet soil. The emerging findings on methane in forests are likely to stir discussions about next steps for climate policy related to forests, which has long focused on trees' capacity to absorb and store carbon dioxide, with little attention to other properties. The thing we know about forests is that they sequester carbon, Covey said. That's what you learn. The reality for climate is more complicated. There is global warming. The 2015 Paris Agreement on Climate Change supports forest projects as a way to draw down carbon dioxide emissions that countries have so far failed to constrain at the source. The United Nations. In interviews, Covey and other researchers looking at the tree methane question stress they aren't arguing that such efforts should pause, noting the many benefits of forest conservation, including carbon storage, resilience against floods, and safeguarding species-rich ecosystems. Independent of climate diplomacy, countries around the world are working to under a separate agreement, the Convention on Biological Diversity, to safeguard their value as home to vast arrays of species. But the methane findings do highlight the importance of assessing the full range of climate impacts for better or worse of different forest and tree types in different regions. As with better understanding in recent years, other studies on the climate system have illuminated how a CO2-centered focus can miss significant additional cooling benefits of forests and in some regions and forest properties significant warming effects. For some forests, all the arrows point in the same direction, Covey said, describing the various ways trees can affect climate. There are other places, he and other researchers said a clearer view can improve climate models and also help ensure that programs centered on the climate value of forests are as effective as possible. In higher latitudes, the simple shift from light reflecting open land to dark, rough surfaced tree canopies can warm the local climate by absorbing more sunlight. Forests in the tropics. Other work has shown how a complicated array of volatile organic compounds emitted by trees react to create haze and clouds, influencing temperature and precipitation in a variety of ways. In 2014, no one interviewed for this story, including Unger, sees that as the case. Now at Exeter U. What's particularly notable now is that she and some of her past critics are all stressing that the prime focus of the world needs to be cutting emissions of carbon dioxide at the source, even as forests are saved for all the benefits they provide. Our best shot at achieving Paris Agreement global temperature targets is a laser focus on reducing CO2 emissions from energy use in the wealthy mid-latitude countries, Unger said. Her point echoes in the March 1st edition of Science on making sure natural climate solutions including forest-focused projects were not seen as an alternative to pursuing deep, prompt cuts in greenhouse gas emissions. Both will be needed. William R. Muah, an emeritus professor of international environmental policy at Tufts University, said there will always be uncertainties in gauging the full mix of climate influences of forests. But that should not, given that forests were major factors in the stable carbon and temperature balance for the past 10,000 years until humans began cutting them down and also burning them, that suggests the balance of all factors was about right. Is the strategic advisor for environmental and science journalism at the National Geographic Society and has. He is the author of Search for Location/City.
Raindrop, drop top smoking, no cooking the hot pot. Fucking on your bitch, yeah, that. Looking up, open the park pot.